All right, let's dive in. Today, we're talking about one of the biggest, most powerful ideas in the entire blockchain world, the smart contract. You've probably heard the term, but we're going to get to the bottom of what it really is. And we're going straight to the source, the original Ethereum white paper, to do it.
So let's start with a wild thought. What if a contract could actually enforce itself? Seriously, imagine an agreement that doesn't just sit on a piece of paper, but actually, well, executes its own terms all on its own. No lawyers, no courts, no arguments. That right there, that's the core idea we're unpacking today.
Here's how we're going to break it all down. To really get what a smart contract is, we've got to understand the problem it was designed to solve. So we'll start with Bitcoin's brilliant but limited design, see how smart contracts came along as the solution, check out how they actually work under the hood, and then, the fun part, explore all the mind-blowing things you can build with them.
Okay, so our story kicks off with Bitcoin. Of course it does. It was a total game changer, right? It gave us the very first truly decentralized digital money. But, and this is important, Satoshi Nakamoto's creation was built for one main purpose, and that focus came with some very specific intentional limits. Now, from a super technical point of view, the Bitcoin blockchain is what's known as a state transition system. That sounds way more complicated than it is, I promise. Just think of it like a giant shared spreadsheet. The state is just what the spreadsheet looks like right now. Who has what? A transaction is just a command that tells the system how to create the next version of that spreadsheet. That's it.
And this table shows it perfectly. Look at that top row. The state is simple. Alice has $50, Bob has $50. The transaction is send 20 from Alice to Bob. The new state? Easy. Alice has 30, Bob has 70. But check out that second row. Alice tries to send $70, which she doesn't have. The system doesn't create a negative balance. It just says, nope, error. This simple, unbreakable rule is what keeps the entire thing secure.
Now, Bitcoin wasn't totally rigid. It did have a very basic scripting language built in. You could do some slightly clever things like, say, requiring 2 out of 3 people to sign off on a payment. It was kind of a sneak peek of what was to come, a really early and you could say weak version of a smart contract.
But that scripting language had some serious handcuffs on it. For starters, it wasn't Turing complete, which is just a fancy way of saying you couldn't do loops, a basic tool for any complex program. It was also value blind, meaning the script could see a transaction was happening, but had no idea how much money was being sent. It had no memory, no state, so every transaction was a one-and-done deal. And finally, it couldn't even see basic information about the blockchain itself. These were the walls Bitcoin was built within.
So yeah, those limits weren't a bug. They were a feature of Bitcoin's design. But they created this huge gaping opportunity for something more. And that something was Ethereum, a platform built from day one to tear down those walls and become a global computer for smart contracts.
So what exactly is a smart contract then? Let's go straight to the source. The Ethereum white paper defines them as systems which automatically move digital assets according to arbitrary pre-specified rules. And that word arbitrary is everything. It means the rules can be anything. Whatever logic you can dream up, you can program into the contract.
I love this quote from the white paper because it gives us the perfect analogy. Think of a smart contract like a cryptographic lockbox. You put digital value inside it, crypto, tokens, whatever, and it will only unlock and release that value if, and only if, certain conditions that you programmed are met. It's a box with its own brain that follows instructions perfectly.
And this was the huge leap forward. Ethereum didn't just add a few more commands, it built a full-blown Turing-complete programming language right into the blockchain's DNA. This meant developers could suddenly build real, complex applications with logic, with memory, with loops, the whole shebang. This one idea completely changed the game, turning the blockchain from a simple accounting book into a decentralized world computer.
Okay, so we've got the what and the why. Now let's get into the how. How in the world does Ethereum's design actually let this self-running code exist and operate securely on a massive global network?
Well, on Ethereum, there are basically 2 kinds of accounts. The first is what you're probably used to, a wallet controlled by you and your private key. But the second kind, a contract account, is something else entirely. There's no person behind it, it's controlled completely by its own code. Think of it less like a bank account and more like a little autonomous robot living on the blockchain, just waiting for someone to send it a message and poke it into doing its job.
So, you might be wondering, if developers can write any code they want, what stops someone from writing a malicious infinite loop that just bogs down the entire network forever? The answer is an elegant little concept called gas. Every single step of a computation, every line of code that runs costs a tiny bit of this gas. If your program is too complex or starts running away with itself, it'll eventually run out of gas and the transaction just stops. It's a beautiful way to keep the network safe and functional.
All right, this is where theory meets reality, and it gets really, really exciting. We've talked about what they are and how they work. But what can you actually do with them? What can you build when your contract is also your code?
The original white paper actually broke down the potential applications into these three main buckets. As you'd expect, about half were seen as purely financial. Think new currencies or derivatives. Then you have this semi-financial category where money is involved, but it's not the whole story. And then there's that last slice, applications that have nothing to do with money at all, like voting.
And this is just a quick look at the kind of things they imagined. You can launch your own tokens, you can build complex financial tools, you can create identity systems that you and only you control, you could build a decentralized version of Dropbox, or you could invent entirely new ways for people to organize online. The possibilities are just huge.
Let's just zoom in on that one idea for a second, DAOs, because they are a perfect example of this power. A DAO is basically an organization that lives entirely in code. It has members, it has a bank account, and all the rules for how it spends its money or how it can be changed are baked into smart contracts. Decisions get made by votes, and the results are carried out automatically by the code. It's like a company with no CEO, no board of directors, just the rules.
So as we start to wrap this up, it's so important to see the bigger picture here. Ethereum and smart contracts were never just about making a slightly better version of Bitcoin. The vision was so much grander than that.
And this quote from the end of the white paper just says it all. The point wasn't to build a handful of cool apps. The point was to build a new foundation, a foundational layer for a new kind of internet, where anyone, anywhere, could build the financial and social systems of the future without asking for permission.
And that brings us to this final, really important question. This technology gives us the power to write rules for money, for companies, for any kind of agreement that are literally unbreakable and self-enforcing. So if code can truly be law, it makes you think, what kind of rules are we going to write? What kind of world do we want to build?